Welcome to this tutorial video. This is for students doing CS 120, in particular students in groups 4, 5, 6 or 7. That's students doing the Morse code encoding and decoding on the Arduino. And the idea of this video is to help anyone who's still stuck on the first week's worksheet, because there's quite a lot to take in. So if you're still a bit stuck, or maybe you finished that worksheet but you didn't fully understand it, then hopefully this video will give you a bit of help. What I'm going to do is I'm going to work through the worksheet, I'm going to write my own solution to it, and I'm going to explain what I'm doing and why I'm doing it. Please don't just copy the code, unless you understand it, of course. If you don't understand the code and you just copy it out, you're not really going to learn a lot, but that is of course up to you. So we're going to get started. The worksheet says week 6 practicals. Section 1, which is the introduction, just explains a little bit about what Morse code is. 1.1 explains how long a dot, a dash, a space between two letters, a space between two words should be. So section 2 is the first bit that actually requires some programming. 2.1 is translating characters to Morse. So we have to write the function which will take a character and will return us the Morse code equivalent of that character. So the worksheet provides a little bit of code that we can start with. So I'm just going to type that in now, and we will go. So as ever with Arduinos, we need to have two functions: void setup, void loop. If you don't have these two functions, your program will not compile. So if I, for example, remove void loop, try and compile that, and hopefully, eventually, yeah, there we go, compilation error. So we get an undefined reference to loop. So we have to have both setup and loop there. Setup will run first when the Arduino is powered up, and then loop will run afterwards, and it will run repeatedly. So it'll run over and over and over and over again. So the code that we have that's been given to us just initializes the serial port. So we call serial.begin. We give it 9600, which is something known as the baud rate, and effectively that is how quickly your Arduino will be communicating across the USB connection to your computer. 9600 is pretty slow, but we're not doing anything that requires any particularly fast communication, so it'll do fine. Next, we're given an example of how our function should be called. So serial.println char to Morse, and that function should take a character. We've also been given the sort of function outline, so we know what we should be producing. So our function should return a pointer to a character. It should be called char to Morse, and it should take a character as a parameter. So the worksheet then gives us, quite handily, a bunch of arrays, handily named things like Morse underscore A or Morse underscore F, and each one of those arrays is the Morse representation of that letter. So for example, Morse underscore A is equal to dot dash, which is the Morse equivalent for the character A. So I'm just going to copy those in rather than type them out, save myself some time. If I can find the, I can't find the code, it's gone. Right. Okay, where's it gone? There it is. So these are the arrays that the worksheet gives us, and we need to use these to return the Morse equivalent of a character. So the solution that I'm going to write in this video is going to be the simplest one, basically. So further on in the worksheet, there are sort of mentions of making things more efficient and things like that. I'm not going to do that. I'm just going to stick to the basics because I don't really want to confuse people. I might, after this video, make another video where I go on and change how I do character lookups and things like that, maybe do some error checking for anyone who might be interested. So, Charter-Morse, we get a character passed to this function, and depending on what character that is, we need to return something. Now we could write a really big if statement, for example, if C is equal to A, do this. If C is equal to B, do this, etc, etc, etc. And that would be fine because it would work. But we have something that could replace that and makes it all look a little bit nicer, and that is the switch statement. So the switch statement, we have switch, and then we give it something to switch on, so something that is a variable. In this case, it's the variable that is passed to the function Charter-Morse, which is C. So when we call Charter-Morse, C will be whatever character we want Charter-Morse to translate into the Morse equivalent. So we call switch and we give it C. We then provide cases. So for example, case A, the character A. So if C is equal to the character A, then we should return something. And what we need to return is Morse underscore A, because Morse underscore A is an array containing the Morse code equivalent of the character A. Now Morse A is an array, and our function is supposed to be returning a pointer to a character. Well, hopefully, if you've been paying attention in lectures, you'll know that the name of an array is effectively a pointer to the first element. So very handily, we can simply type Morse A. So we're going to return a pointer, so a character pointer in this case, to the first character in an array of characters. And that array of characters represents the Morse code for A, the character A. So if I compile this, yeah, you'll see that it works fairly well. Well, it doesn't work very well, it compiles at least. So it doesn't do anything particularly useful. All it will do at the moment is translate the character A into its Morse code equivalent. So I'm just going to plug in my Arduino, and I'm going to make sure that that works, because it's important when you're programming to sort of work in small steps and test things as you go. So I'm going to plug in my Arduino, which is an Arduino Uno. Yeah. Okay, I'm going to program that, and we're just going to make sure that it works. So let's have a look at the output. Okay, so you can see the output is a dot and a dash, and that's because we've called Charter-Morse and given it the character A. So that's not particularly useful because all we can do at the moment is translate A. But making it better is not particularly hard, it's just a little bit tedious. So we just need to provide cases for all of the other letters that we want to translate. For example, B, etc, etc, etc. So I am going to go and type that all out because it's pretty boring to watch, and we'll pick up when I'm done. Okay, so we now have cases for A to Z, and if I compile that, it should compile fine. So as far as section 2.1, translating a character into the Morse equivalent, we should be pretty much done, and I'm going to quickly test that to make sure. So I'm going to try a few more characters to make sure that they also work. I'm just going to pick a few at random. So H, Z, something like that. Quickly upload that and make sure that my program is actually returning the correct Morse for the correct letter. Okay, so we get dot dash for A, dot 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 for H, and dash dash dot dot for Z. So you can see here Z, dash dash dot dot H is dot 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 dot, and A dot dash. So that's working nicely. Task 2.2 then goes on to say how to handle non-Morse characters. So what this means is characters that cannot be represented by Morse code. And it says that char2Morse receives a char, and Morse cannot represent all 255 possible values. Why 255? Well, because a character or a char type is 8 bits. So 2 to the power of 8, 256. So we could have 255 possible values represented by a character in our program, but Morse code only represents A to Z. So we then have to extend our function so that all characters are treated appropriately. It says that character case should be considered and that interword spacing is handled in Morse. So the first thing to do is to handle characters that we don't understand or that we can't translate into Morse code. So one thing to do would be to have a default case in our switch statement. Now this is a case that will happen if none of the other cases match. So if we give char2Morse a character that is not A to Z, then none of these cases will match and the default case will be run. And a default case could just be to return something, I don't know, let's use, well, we could use a question mark, I guess, and we'll just call it Morse unknown, something like that, and we'll just create up here a new array, char Morse unknown, and we'll just say that's equal to a question mark. So now if I give char2Morse something that it doesn't understand, for example 7, and we test it, we should see that actually we get a question mark being printed back because char2Morse does not understand 7. Where's it gone? Right, there we go, question mark. So we now need to handle uppercase values because it's quite possible that instead of typing A, we could type A like that. So we need to handle that. So there's a handy function which is called toLower, and toLower takes a character, and if it is uppercase it returns the lowercase version of it. If it's lowercase then it just leaves it as is. So we can say that C, or the character that's been passed to this function, is equal to the lowercase version of C. So in this case, char2Morse with a capital A being passed, C is going to be the capital A, so we call toLower on a capital A, which gives us a lowercase a, and C becomes a lowercase a. That lowercase a then gets passed into our switch statement, which can match on the first case, which is a lowercase a, and return the correct Morse equivalent. So again, we should quickly test that. If we give it a capital A, then we should get a dot dash if this is working. If it wasn't working, then our default case at the bottom here would return Morse unknown, which would be a question mark. So hopefully we get dot dash, and we don't because I haven't uploaded it. Okay, a dot dash. So we've now finished sections 2.1 and 2.2, and we will move on to section 2.3, which is translating a string to Morse. And what we mean by a string is a string of characters, otherwise known as an array of characters. Again, we've been given a little bit of code to work with, which I will type out again up here. So we've been told that we have a character array called T, and that is equal to Morse code. We've then been told that the function should be called string to Morse, and it should take our array of characters. We've also been given a sort of function skeleton for string to Morse, so it should not return anything. It should be called string to Morse, and it should take a pointer to a character, which will be our buffer. So what this means is that buffer should point to a character, and we are expecting that where it points is the start of an array that will contain the string to be translated. Okay, so in this case, buffer, which is a char pointer, should point to the start of T, which is an array. So it should effectively point to M. Okay, so we need to take this buffer, we need to sort of separate it out into its individual characters, and we need to output the Morse code equivalent for each of those characters. So to do this, we probably need to know how long this is, so that we can loop over it the right number of times, so we can figure out how many characters are in it. So there's a function that does this for us. It's called strlen, so it stands for string length, and we're going to give it buffer. And actually, I'm just going to change the name of buffer because it's not particularly descriptive, so I'm going to change it to text to convert, because that's just a little bit more descriptive of what it is. Okay, so strlen of that, so strlen of text to convert should return us the length of this array here. So if we get an integer called length and we assign it to the result of that, we should, if we print this out, get the length of that string. So it should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see if it is. Stupid window. Right, there we go. You can see it is 10. So that's good, because now we know that we can find out how many characters are in the string being passed to our function. So we can quite easily now loop over that string the right number of times. So we're going to write bog standard for loop. So we're going to start at 0. We're going to increment I by 1 until we get to length. So I is going to start at 0. In this case, it's going to be incremented 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And when it's 10, I will no longer be less than length, which is 10, and this for loop will exit. So inside this for loop, all we need to do is print out the Morse equivalent of an individual character. So we already have a function to do this. We have a function called char to Morse, which we just wrote. That function needs to take a character, and we also have the character that we need. The character is stored in in text to convert, So text to convert, which is basically, we can pretend that it's an array because it's a pointer to a character which represents the first item in an array, and we can access the particular character that we're looking for using I. So the first time around this loop, I will be 0. So if I is 0, then we're going to get the first element in the array, and this is our array. So that's going to be an M. The second time around this loop, I will be 1, so we'll get the second item, which will be an O, etc., all the way to the end. So this will convert a character into the Morse equivalent, and we just need to print this out so we can see that it's actually working. So we're just going to do print line so we can see each individual character, and we're going to upload that and see if it works. Hopefully it does. Hey, lots of characters. So we've got M, O, R, S, E. We have a question mark, and that's because we don't have a Morse equivalent for a space. So it doesn't understand what a space is, so it just substitutes space for a question mark, and then we have COTE. So that seems to be working nicely, and we now have a function that will convert a string of characters into a well, it will take a string of characters and it will output the Morse code equivalent for all those characters. Task 2.4 is to do the same thing, basically, but instead of printing out each character individually, we want to store the Morse code, and we want to store that in a character buffer somewhere. So again, task 2.4 gives us a function which should be void string to Morse string. This should take a pointer to a character which is the input. It should take a pointer to a character which is the buffer, and it should take an integer which is how long the buffer is. So before I go on to write this function, I'm just going to add a few things up here. Firstly, we're going to need a buffer to store our Morse code in. So we just want another array. I'm going to call it Morse buffer. And the size, I'm going to actually do a hash define buffer size to be 100. And we're going to use that to set the size of the array like so. And I'm also going to use that when I call the function to provide the buffer size. This means that I can change the size of the buffer very easily just by changing this hash define up here. It also means that I can guarantee that the value that I pass to string to Morse string, the buffer size value, is the same value that the Morse buffer array was initialized with. So hopefully that should help eliminate some of the some strange problems that people might have had. So I'll call string to Morse string, and this takes some input. So let's give it hello world. It takes a buffer, so let's give it Morse buffer, and it takes the size of the buffer, which we have buffer size. Right, now I need to write string to Morse function. So what we were doing before was almost there. We iterated over each character in the array provided, and we found the Morse code equivalent. What we did not do was store it, we just printed it out instead. So as you can see here, we just called serial.println on the result of that. So we don't want to do that. We actually want to store that value, that Morse value, into our buffer here. So we can sort of use the same sort of layout as the string to Morse function. Let's get the length of the input in this case. So strlen input. So now we know how long it is. Actually, before I go on, it's worth noting that strlen works by starting at the beginning of this array of characters, and it basically checks, is that character equal to a null terminating character? And if it's not, it carries on going. This means that if you are not careful and you give it an array of characters with no null terminator on the end, strlen will not give you the actual length of the code because it will never find that null terminator, so it will keep on counting. It may be that eventually it finds a null terminator somewhere else in memory and then returns you a number, but that number will not be what you expect, and it may well be that it just reaches the end of memory before it finds a null terminator. So in this video, I'm not checking whether strlen is giving me a sensible value back because I don't really have time to do it. But we're just going to assume that the value returned by strlen is genuinely the length of the array. Okay, so we have the length, and we can do the same thing as we've done in string to Morse, and we can loop over that. Instead of printing it, we actually want to add it to the array, the buffer array here. And I'm going to use another string function that's provided by C, and that's called strcat. That stands for string concatenate. It takes two parameters. The first is the array of characters in which to concatenate to. So in this case, that is buffer. The second parameter is what you want to concatenate. So this is where you want the chart Morse, the Morse code, to be added to. Hopefully that makes sense. If I do this, then, well, yeah, if I do this, it will work, but all our Morse code will be stuck together with nothing in between the individual letters, so it will be a little bit hard to see what's going on. Oh, that didn't compile. Why did it not compile? That's because I used the wrong variable name. Whoops. Let's try again. Let's see if that worked. Of course, that's not actually showing if it works or not because I'm still not doing anything with this. So I forgot to actually print out the results of this. So we're just going to print out buffer, and I'm going to comment out string to Morse here. Let's try compiling that again and looking at the result. Okay, so here we go. Have hello world in Morse code. Again, we have a question mark because space we don't know what to do with, and it's slightly hard to tell what the letters are because they're all glued together, which is a bit of a problem. So let's make it a little bit clearer. And after we've concatenated the Morse code equivalent for a character, we will concatenate a sort of a separator. So we're going to find the Morse code equivalent of a character, we're going to add it to our buffer, we're then going to stick a let's stick a backslash, I think, afterwards. So this means that it should be easier for us to see what is a Morse code character, because they're all dots and dashes and it's slightly harder otherwise. also means that when it comes to turning our Morse code back into characters, we can actually tell where a Morse code character ends. So I'm just again going to upload that and see what the result is. There we go. So now we have HELLO space, which is a question mark, and then WORLD. So I'm going to stop there for this video. That is section 2.1, 2.2, 2.3, 2.4. So we can now take a character and turn it into Morse code, and we can now take a string of characters or an array of characters and turn that into an array of Morse code.